all to my channel CSNL Lectures. So in the last classes we discussed regarding data structure. Okay, its introduction is various types of data types, and also we discussed regarding its abstract data types. Alright, so today in this session we are going to discuss about stack data structure. Right? So what is essentiality in discussing this data structure and why it is seems to be very important. So all we are going to see now. Okay, so a stack is a very important topic in that of the data structure subject. Okay, so it is one type of a linear data structure. So in the previous classes we discussed regarding linear data structure, isn't it? So what is a linear data structure? So linear data structure is used for storing the elements that belonging to a single variable, okay, in a consecutive manner. That is, the memory addresses are going to get arranged in a sequential manner. So it is easy for us to access the element as well as its memory addresses very easily. Clear? So the stack is also going to construct the elements in the linear manner. Okay, so next is stack is used for constructing a LIFO method, that is LIFO. So what is the expansion of LIFO is? It is last in first out method. So all the elements of a stack are going to get arranged and going to get accessed in this method, that is a function of last in first out method. Okay, so now I am going to tell how the elements in a stack are going to get stored. Generally, what is the meaning of a stack? A stack is nothing but we are going to arrange some books or some items or any other materials in a one by one order. Okay, so the items will be one above the other, isn't it? So that is the same here also. So the values or the data, information what we are going to store in a memory are going to get arranged in the rack format. Okay, so that is called as a stack here. All those data are to be referred by using a single variable. It may be by using a array variable or it may be by using a pointer variable. Clear? So the elements are going to get arranged in a shelf format. That is the main thing in stack, right? And another thing is that stack is a very important topic. So in examination point of view, if you see, you are definitely going to get one or two questions. It may be a practical oriented questions or it may be a theoretical problem. So you should have to be confident in stack concept. Okay, shall we proceed? Okay, so now I am going to tell how the stack is going to look like, right? So stack, if you see, a stack is going to get arranged in this order. A stack will be in this order as I told, it is in a shelf format or in a rack format. So the elements will be like this. Okay, so the values or the data is going to get arranged or stored from bottom to top. Okay, for example, any values 22, 34, 35. So like this, we are going to arrange the elements that are all going to get received from the system will be arranged in this order. Okay, so that is the main concept of stack. And another one main term is we are going to use a pointer. Okay, so we are going to use a stack pointer. We are going to use stack pointer. So this stack pointer is going to point out the topmost element of a stack. Okay, so what is the topmost pointer? So the topmost pointer is this one. See, as I told, stack is going to refer the elements or access the elements by using last in first out method. That is, we are going to retrieve the elements or extract the elements that has been pushed into the stack in the last stage. Okay, so element that has arrived at the last is going to be retrieved. We are not going to disturb those elements which are present at the bottom. So the lowest level of elements will not be disturbed. We are going to access and retrieve the elements only at the topmost position. So here the topmost position is this. This is the topmost position, which is called as a stack, pointer. So by using this pointer, we are going to refer the topmost element, right here. So I'll give you a recap. A stack is a collection of elements which is going to get stored in one variable, and we are going to arrange the elements from bottom to top, and we are going to store the elements at the top, and we are going to retrieve the elements at the top. We are not going to disturb any more elements that are present at the bottom of the topmost element. Clear? So that is the main concept of stack. Clear? So now we will see what are the different types of operations that are present in a stack. Okay, see, I have listed it out. So there are around 5 main operations that we are going to do. In the 5 main operations, the first 3 are very important. So okay, so push, pop and peek. So these are the 3 main operations that we are going to perform on the stack. So now we will discuss what is the meaning of push operation, pop operation and peek operation, right? Okay, now we will discuss what is the meaning of push operation. Okay, so the main syntax of push operation is stack name, comma, item. This is the syntax of push command. So when you are typing the command as push stack name, that is name of the stack, that is the name of the place where you are storing all those variables in the stack format, that one, and the actual item what we are going to push. Okay, so this is the syntax of push. Once if you execute this push statement, so the item, for example, let this stack name be, for example, let it be uh, what to tell, register number. Okay, so this is the name of the stack. Okay, I have entered here for an instance 3 register number. Okay, see, if you visualize, you'll be able to see. So the first register number is 22, then 34, and then 35. For example, if I am going to enter another one register number, where it is going to get stored. So where it will be stored? It will be stored in the, it will be stored in the topmost position, right? So the syntax for that is, so see here, push, what is the stack name? So stack name is, for example, register number. So what value I am going to push? For example, let it be 48. So once this system is found, so the element 48 is going to get stored where? It will be stored in the topmost position. Okay, so it will not, another thing you must have to remember is directly we cannot store the element. So see in this diagram, the pointer is going to play a very vital role. Okay, by navigating the pointers up and down only, we have the possibility for removing the element or inserting the element. Okay, so now you watch keenly. I have given this statement. How now how the value is going to get stored in the stack. So the value will be getting stored in the stack by means of this top pointer. How? Now what will happen is, first we must have to increment, that is move the position of the top pointer towards the next position upward. That is, upward means towards the next empty position, because as I pointed out here, the topmost pointer was pointing to a location which already has a number 35. Suppose if another element is coming as 48, if I directly store the element, what will happen? So this 35 will be erased and will be stored as 48. And another thing is that this type of execution is not possible. You will get an error. So what process you should have to follow is, you must have to first increment the pointer to the next empty location. Okay, so after it has been moved, then only this 48 will be stored, right? So with the help of the topmost pointer, you are going to store the next element. Clear, right? So now we will see the another operation, what is called as pop. So the meaning of pop is nothing but deletion. Okay, so the meaning of pop is we are going to delete one by one the element, right? So what is the syntax of this deletion operation is, just you give pop of the corresponding name of the stack. So here stack name. So once we have given the statement, automatically the element that is present or the topmost element will be deleted. Okay, so that is the meaning of this syntax. Okay, so now for example, I am giving for this example structure. So instead of stack name, what is the name of the stack here? So the name of the stack is here register number. Okay, so once this statement is given, what will happen? So the element that is present at the topmost will be deleted, isn't it? So here the pointer which is pointing to the topmost element, so the topmost element here is 48. Okay, so now this 48 will be deleted. Okay, this 48 will be deleted, and next what will happen? I must have to decrement. Okay, because I must have to decrement the pointer. Why? Because this top pointer is now pointing to an empty location which is not having any use, right? So now the topmost value is 35 because I have deleted the 48. Okay, so now what you have to do is, I must have to decrement this pointer to point to the next top value. So here the next top value is 35. Okay, so this is the way you must have to extract or put the elements. Clear? Have you understood? So next we'll go for peak operation. Okay, so what is the meaning of peak? So peak is nothing but it will give away. It will not push or it will not delete any element. Just it will tell us that what is the topmost element of the stack that is being present. That's all. So for example, if I give as peak, what is the name of the stack? It is register number. So what it will do? So once the statement is executed, your output will be having the value that is present at the topmost. Okay, so here the topmost element is 35. This is your output. Clear? So we have seen what is push operation, pop operation and peak operation. Okay, are you all clear with this? Okay, next we will see what is empty or is full. Okay, so before discussing this statement, these two syntaxes, I must have to explain you what is overflow and underflow. Okay, so now shall we discuss about what is an overflow, what is an underflow? Okay, first we will see what is an overflow statement. Okay, so this overflow statement, it is related to that of push operation. Okay, so again this underflow statement will come with that of pop operation. Now can you guess what is the meaning? So what is overflow? If the size of the stack exceeds the limit what we have fixed, that is called as overflow. Okay, so now I will tell you here with an example. For example, this register number size, for example, we have fixed the size of the stack value as, for example, 5. Let it be integer. We have declared an array variable, it is called as a stack. So the fixed size of the stack here, it is 5. So what is the meaning? I can store only maximum 5 elements. We cannot able to exceed. Okay. Now already we have 3 elements. So by using the push operation, okay, I have inserted 2 more elements. For example, already 49, and then it is 51. So I have stored 0, 1, 2, 3 and 4. So maximum of 5 elements I have stored. Okay, so now where the top pointer will be pointing? So the top pointer will be pointing here. Okay, so now the top pointer is going to point here. So again, for example, if another element is going to come, what? If another element is going to come, is it possible for this stack to store? No, we cannot able to store no more elements. So the system will tell that the stack is already full. You cannot able to enter the forthcoming elements. Okay, so that type of checking is called as overflow. Right? Now what is the meaning of underflow? So what is the meaning of underflow? So it is going to relate to that of pop operation. So now uh, I am going to delete this stack element. For example, now fourth element is deleted. Then the pointer will be pointing here. Again, I am deleting the third element. So once again, I am deleting the second element and the first element and the zeroth element. And after deleting all the successive elements, if I attempt to delete still more elements, is it any chance for? Is there any chance for it? No, there is no chance because already the stack is empty. How can I able to delete? So we cannot able to delete it, right? So the system will inform that the stack is empty. You cannot able to pop the elements hereafter, right? So this type of checking is called as underflow. Clear? Now are you all clear about the meanings of these important points? Right? So that's all about stack operation. So in the next video, we are going to discuss about the push algorithm and pop algorithm. Okay, so you must have to understand the steps of executing those algorithms because you will be getting questions even in this. Okay, and also in algorithm point of view also you will be able to get a question, right? So here I have mentioned as push down list. What is the meaning of push down list? It is the other name for stack. Okay, that is the other name for stack is push down list. That you can make a note of it. That is where the elements are moved from. Sorry, once the element is coming, we are moving in this direction towards downward. So we call it as a push down list. Just to note the meaning, it is enough. Name is push down list. Okay friends, clear? So now that's all about its general concepts and its important points. So now in the next class we are going to discuss about the algorithms that are going to get present here. Okay. So friends, so we have discussed today regarding stack data structure and its various operations. Okay, in the next class, we are going to discuss regarding its very important algorithms and some of the important questions that may arise in those topics. Okay, and thanks for watching, and I also request you to share this video to as many people as possible so that they may feel it as a very helpful one. Okay, thanks for watching and thank you friends.